Okay, so does everyone have their videos for today? Did you get your notes? No? Yes. Brand new note packet. Okay. Does anybody else need notes? Brand new packet. No? Zach. Who sits in front of you? Nobody? Okay. All right. So perhaps the most powerful of all equation solving techniques is what is known as the zero product law. So the zero product property or zero product law says any number multiplied by another number, if that equals zero, like if I have two numbers multiplied together and the product, the result is zero, that means one of those numbers has to be zero, right? The only way that you're going to get two numbers multiplied together to equal zero is if one of those are zero. So we're going to start off with example A. It just says for each one of these sets of numbers, you need to come up with 3 ways to write that product. 3 different ways to write that product. So here's what this means. So for the number 12, what is one way that I can get the number 12? 12 times 1. Yes, I can. And our pen is officially dead. I'd bring one in from home. Okay, so I can do 12 times 1 here. 4 times 3. Yeah. So I have 3 different ways that, and there's much more, right? Like I could do -4 times -3, -12 times -1, -2 times -6. I could probably do like 1.5. Let's see, half of 3 is 1.5. So I could do 1.5 times 8. I could do decimals, fractions, right? There's multiple ways to do that. What are 3 ways that we can get a product? 3 ways that we can get a product of -24. Give me one. -2 times 12. Are you guys okay if I just put it in a parenthesis like that? 6 times what? 6 times -4. And 8 times negative, dang it, -3. I know that little spot right there looks weird. So 6 times negative, so 2 times, -2 times 12, 6 times -4, and 8 times -3. And again, there's other ways to do that, right? Okay, someone give me 2 numbers that I can multiply together to equal 0. 1 times 0. Mm-mm. You don't know what infinity is, do you? Nobody does. You can't even multiply by infinity. It's too big. What else? What's a 0? 3. Did you say 3 times 0? Oh, 100 times 0. Yeah. What about 30 times 0? How many different combinations could you come up with? Infinitely many. Yep, for sure. That's what you meant? Yeah. Infinitely many ways to write something times something else equals 0, as long as you can use the number 0. So what it's saying here is hopefully that you noticed from exercise 1 that we just did that the only way that you can get something to equal 0 in a product is if you multiply it by a 0, meaning if the product of 2 numbers equals 0, then one of those numbers must be 0. So that's what the zero product law or zero product property says. So it's using just plain variables to explain that. So if m times n equals 0, then what does that mean? If those 2 variables equal 0, if the product of those 2 variables, if I multiply those 2 variables together and they equal 0, then what does that mean? Either m equals 0 or n equals 0. That's what it means. One of those numbers has to be 0. That's the only way to get a product of 0. So hopefully these numbers down here in exercise 3 look familiar to you. So we use the zero product law to find the zeros or the roots of a quadratic. So we are going to find the zeros. It has multiple names. It's called the zeros, the roots, also known as the x-intercepts. And lastly, it's called the solution. And that's what we're gonna call it solving. We're gonna solve quadratic equations. So the way that you do that is, first of all, you set it equal to 0. And if the quadratic equation is already factored, that's much easier. If I were to look at this and say, what did this start as? If I wanted to know what trinomial this was, how could I figure that out? What method would I use? FOIL, yeah. If I wanted to figure out what trinomial this was to begin with, I could FOIL it out. So x times x is x squared. -5 plus 1 is -4x minus 5. That's what this started as. This binomial product right here started as this quadratic equation. I want to be able to tell you the two solutions. I want to tell you the solutions to this quadratic equation. Well, the solutions to this quadratic are that either x minus 5 equals 0 or x plus 1 equals 0. So I'm trying to solve for x. I'm just going to solve for x. So let's look at the x minus 5 equals 0. If I want to get x all by itself, if I want to find the solution or the 0 or the root, how would I do that? I'm looking right here. I want to solve this equation right here. I would add 5 to both sides. You're exactly right. Add 5 to both sides, and I find out that x equals 5. That's the first solution. What about the next solution? What would I do with the x plus 1? Trying to solve for x. Subtract 1. So that means x equals -1. So these two values, x equals 5 and x equals -1, are the roots or the x-intercepts or the solution. I want all of you guys to grab a calculator. And tomorrow, I was supposed to do that today. Tomorrow, you guys are going to have a specific calculator assigned to you, like a number. But I want you to grab a calculator and go to your y equals really fast. I want to show you how to check this. So you could either use the trinomial form, y equals x squared minus 4x minus 5, and don't put the equals 0. We started off with y equals. Or you can use the factored form. I'm going to use the factored form. So I'm going to put parentheses in my y equals table. I'm going to put parentheses x minus 5, close my parentheses, new parentheses x plus 1. And I just want to show you that when you do that and you go to the table, so after you put in your equation, whether you put it in its trinomial form, like the unfoiled form, unfactored form, or the factored form, either one of those, when you go to the table, just don't put equals 0. Do not include the equal 0. Pardon me? Who said what? Did you? So go to y equals.
Okay, yeah, I heard that.
Okay, and now you're going to go to your table. So go to the table. And when you go to the table, what do you see? Well, I want you to go to where x equals 5 and where x equals 1. Huh? Yeah, we were doing some crazy stuff in math 3. So you can reset it and it'll get you back to a normal. What happens when you go to, like when x is -1? When you go to that input, what's your output? 0. That's what we want it to be. What about when x equals 5?
Do I divide -1 by x?
You're just going to find -1 on the x-axis, like the x input table. No. You're putting in this equation. You're putting in this equation first, right? So put in parentheses x minus 5, and then parentheses x plus 1. And then go to your table. So when x is -1, you get an output of 0. When x is +5, you get an output of 0. Okay, so what do you get when you go to your table? Second graph. We've been doing that forever. Second graph. So when x equals -1, you should get an output of what? 0. And when x equals 5, you should get an output of, those are called the solutions or the roots. Solutions or roots. We also said that that was an x-intercept, right? Didn't I write up there that the solutions or roots is also an x-intercept? Someone tell me what an x-intercept means. What does it mean when I say x-intercept? Yeah, that's where this crosses over the x-axis. So I'm going to draw something. Please don't copy it because we're not ready for that. But I just want to show you what this means. You do not have to do this. This means at -1 and at +5, my graph is going to look something like this. It's crossing at -1. Don't draw this because I'm going to erase it. And +5. That's what those roots mean. They tell us where the graph crosses the x-axis. Okay? Pardon me?
Graph, I don't know what it's called.
A parabola. That's what a quadratic makes. It's a parabola. Good job. All right, let's do example B. Example B. So the first thing that we have to do, we're trying to solve, right? We're trying to solve each one of these. What do I do with this 5 out front? Well, I'm trying to solve. I'm trying to get the two factors all by themselves. So what if I divide both sides by 5? What happens? This becomes a 1. And what happens over here on the 0 side? What's 0 divided by 5?
0.
It's 0. So I still have x plus 3 equals 0 and x plus 4 equals 0. Now, Reese, I'm going to kind of put you on the spot, and if you want to bow down, you can, but you said something really interesting on the last example. You said that when we were looking at this last example and solving it, you said that they're the opposite. What do you mean by that? Yeah, when you did this one, when we were solving them, you said to yourself, oh, they're the opposite. What did you mean by that?
-5 plus 5 equals 0. Just none of those ones thought process, I guess.
You're right. So this is what Reese said. He's like, oh, well, x plus 3 equals 0. That means x has to be the opposite of a +3. So what does x equal? It equals -3. And if x plus 4 equals 0, that means x has to be the opposite of a +4, which is what? A -4. So the roots or the solutions, these two x values, are actually the opposite of what the factors are. Does that make sense? So if you have x plus 3 as a factor, that means that the root is -3. Let's do example C. So example C, I have 2x equals 0, or I have x plus 6 equals 0. If I use Reese's idea of them being opposites, x plus 6 equals 0, that means x equals what? X equals -6. For this top example, 2x equals 0, I have to get x all by itself. What is the opposite of 2 times x? Yeah, divide by 2. What is 0 divided by 2, Madeline? 0 divided by 2 is 0, yeah. So these are my two roots. X equals 0 or x equals -6. I think we have one more example over there. Yes? No? Okay. So it has a couple of questions for us. It says, in example B, Why is it okay to divide by 5 first? Why did we divide by 5 first? Yeah, we were trying to isolate the factors, and it's okay to divide by 5 because 0 divided by 5 is still going to equal 0. Yes, that's why it's okay. But in example C, why did we not divide both sides by x? Like, why can't we divide by x? Well, because we don't know what x is, right? Do we know what x is? Like, hypothetically, before we solved it, did we know what the value of x was? Yeah. So we cannot divide by 0. We cannot ever divide by 0. And we did not know the value of x. We didn't know what x equals. So if you don't know what x equals, like, it's a variable, right? You don't know what it equals, so you can't divide by it. You don't know what it equals, so you cannot divide by it. And again, like I said, we never, ever, ever divide by 0. So go to example or exercise number 4 at the bottom. Exercise number 4. And so this is a multiple choice question. It just says, which of the following, which of these choices is going to be the solution for this equation? So I want you to think again about what Reese said. So Reese said that the solution to x minus 4 is the opposite. So what's the opposite of minus 4? Plus 4. So this is x equals 4. So the solution to x plus 7 equals 0 is x equals negative 7. And so the solution is number 2. Our answer choice is number 2.
It's that problem right there, the problem of elimination, process of elimination.
You could do this by the process of elimination, knowing that 14 and 8 would never work. The 2 is not going to work, but it's easier to just know that they mean opposites. So this is easy when the equations are already factored for us, right? These were already factored. So on the back side, they are not factored for us. On the back side, they are not factored. So we have to factor them first. We have to put those quadratic equations in factored form. So the cool thing is on this first one, the value of a is 1. And I know that when a equals 1, the factors that I choose and use. Yeah. So let's see. 1 times 10 is 10. Just flip it over. And I have to add to b, which is what? 7. What are two numbers that when I multiply them together, I get 10, but when I add them, I get 7? 5 and 2. And they're both positives, 5 and 2, right? So that actually means that my factors are x plus 5 times x plus 2. And we're going to set it equal to 0 to solve it. So what are the two roots or the two solutions for this quadratic equation? Good job. X equals negative 5 and x equals negative 2. Does everybody understand that we know that the solution is the opposite of the factor? Does that make sense? Okay. Let's look at B. How are we going to factor that one? It is a perfect, it's the difference of two squares, right? So what's the square root of x squared? X. And what is the square root of 25? So I do plus 5 minus 5 equals 0. So what are my two roots or my solutions or my x-intercepts for this quadratic equation?
X minus 5 and x plus 5.
So x equals negative 5 and x equals a positive 5. And I want to show you another way that you can write that. You can actually write it as x equals plus or minus 5. You can write that like that. When you have the same number, but both the positive and the negative of it, just write it one time and put a plus minus in front of it. Is that okay with you guys? You don't have to, but you can. Okay. Catherine, what do you think about example C? Is there a GCF in there? Madeline, you say yes. What can I take out? A 3. What else can I take out? A 3x. I'm going to divide a 3x out. So when I take out a 3x, what do I have left? Yeah, I have x minus 5. So that means that 3x equals 0 or x minus 5 equals 0. So what are my two values of x? What are my two roots or my two solutions? So x equals 5, right? And 3 times what is going to give me a 0? It's the zero product property. 3 times what is going to make a 0? 0. 3 times 0 equals 0. These are my two roots. If this one is like twisting your brain, remember when you have 3x equals 0, to get x all by itself, you're just dividing by 3. So that's why x equals 0. Okay. Thoughts? Okay. Is this making sense? Okay. So here it says to use the values of x, use the store in your calculator, but this is an old calculator. This is like a scientific, not a TI-84. So you're actually going to use what are we using to find the roots? Yeah, we're using the y equal and then the table. We're going to use the y equal and then the table. So we really don't have to factor these. I'm going to factor them and then we're going to check them using the y equals and the table. So I'm going to factor these two examples and then we'll check them using y equals and the table. So what's the first thing that I can take out of for A? Does it have a GCF? A 5. Yeah, I can divide everything by 5. I can even divide that by 5, right? Because technically you divide everything by 5. So I pull a 5 out, and that leaves me with x squared. You can. Minus 3x minus 40. Oh, my battery is low. Stop, stop, stop. Don't. Cord. Power. Okay. All right. So, So how are we going to factor x squared minus 3x minus 40? Let's see. Times my times side and my plus side. Let's see. 1 times negative 40 is negative 40, and it has to add up to a negative 3. Okay. So what two numbers can I multiply together? What are two numbers that you can multiply together to get 40? 2 times 20, 4 times 10, 8 times 5. What if I used a negative 8 and a positive 5? Would that work? Negative 8 times 5 gives me negative 40. Negative 8 plus 5, gives me negative 3. So my factors are 5 times x minus 8 times x plus 5 equals 0. So if those are my factors, what are my roots? What are the two values of x that make this true? Good job. X equals positive 8 and x equals negative 5. Very good. So are you guys definitely understanding that the root is the opposite value of the factor when x is 1? Okay. What do you think about that next equation? What can I do? Is there a GCF? What is it? a 2. When I take a 2 out of everything, I'm left with x squared minus 7x plus 10. Okay. So how does that factor out? Let's see, times plus. 1 times 10 is 10, has to add up to a -7. Yeah, -5 and -2. And when a is 1, the factors that you choose are the factors that you use. Put my 2 out front. So what are my 2 roots? X equals +5 and? Perfect. What are the ideas on this? Not bad. You guys understand it? Okay. We're going to divide up into 2 teams. Team 1 has 1 and 3. Catherine, you're in charge. Pick, how many people are in here today? 2, 4, 6, 8, 10, 12, 14, 16. Pick 7 people.
Oh, what's that symbol?
It's a comma. -5, -2. Who are your 7? Just point at them. So 1, 2, 3, 4. Okay. You need Maddie, Austin, and Logan. Okay, so Maddie, Austin, and Logan, move over there with that group. The rest of you guys go over by Gavin and Zach. You can. Go on. Go on. Okay. So, Catherine, you guys are doing examples 1 and 3. So this is Catherine's team. And are you running to the restroom? All right, Zach M., you're in charge. So Zach M., as soon as Gavin gets back, you can go. Gavin, I need to give you a pass. Zach, you have 2 and 4. You guys are in charge of 2 and 4. You guys have 1 and 3. Gavin, 3, 9. Reese, you're over there with that group. Okay. You can. Yes. I want you to go with your group and share with them what you figured out. Brian, I have your pass ready. When he gets back, I'll put a time on it. You can sign out and go.